Everyone, welcome back to our week 3 for data analytics and machine learning. This week we're going to go through a chapter which is a very important chapter, which is actually all about data pre-processing. As I said earlier, this data pre-processing topic is the most important part in any kind of machine learning. Okay, whatever data analytics method you wanted to use, whatever techniques, whatever frameworks, whatever modeling that you wanted to use in the data analytics, first thing first, you must start everything with the data pre-processing. So that is the kind of topic that we're going to cover today. But before we do that, just a quick announcement, revision, okay, from what we have learned last week, and as well from what we discussed on the first week regarding your group assignment. Yeah, I've already uploaded in your My Times, okay, the group assignment company. So far I've secured 4 companies. 3 are coming in, but I can't wait for that 3 companies. I know earlier I said 20 numbers of company interested, but after the meetings, they kind of like, of course lah, data companies, no one can actually, it's very confidential. But 4 is good for me because last year I only had 2. Okay, so this year I got 4, and 3 are coming in. So if the 3 are coming in, then maybe we can have an extra option to those who are still not having a company. So please go to your My Times. Okay, and then please register your company here. I've already put all the details on the company, the person in charge. At this moment, we didn't share the contact number, the mobile number. So it's your responsibility to initiate the communication with them through the email address. Okay, and then I will also communicate with them. If I got their contact numbers, and if they allow me to share the contact number with all of you, then I will share with all of you. Okay, but whatever it is, by this week, please start this group assignment. Okay, I've already put inside the My Times. We have around 69 number of students, maybe more, maybe less. Okay, so I put around maximum 16 numbers of groups, okay, to participate in this group assignment project. 4 to 5, yeah, maximum 5, minimum is 4 lah. Okay, don't have less than 4 numbers of group members. As I said, this is quite crucial to have enough number of group members. Otherwise, you will have a problem later on, especially when you want to start on the data collection. Data collection is the most headache part lah. Okay, like I said, companies' data are very confidential. Okay, some of them, they may give you a very little amount of data, so you must start to do and learn about the data augmentation. Okay, you have to learn about how you can pre-process if they have any kind of outliers, anomalies, type of data that which we're going to learn today. Okay, so that's why you have to start to form your group by end of this Friday. Is it okay? Is it okay? So all the announcement about the group assignment, I've already put inside your My Times. Okay, you must have 4 to 5 group members. You are free to choose your own company. It's a first come first serve basis. Okay, if the company's list has been completed. Okay, so for example, I think every company will have around 1, 2, 3, 4 maximum, 4 groups per company. Okay, so it's first come first serve. You can have a look on the company's background, search about the company's history and everything. So hopefully that will give you some idea which company suit you the most. Is it okay? Okay. Okay, and then like I said, please initiate the communication with the company as soon as possible. And the last date for you to form your group is this Friday before 5 p.m. After 5 p.m, I will remove the link for the Google Sheet. Okay, so you have to form your group as soon as possible. 4 to 5 members. Maximum is 5. I don't allow any more than 5. Okay, minimum is 4 if possible. If you cannot get more than 3, let me know. Okay, maybe we try to find out on how we can actually solve the issue. Okay, but like I said, ideally it's 5. So please get at least lah, try your best to get 5 group members in the group assignment. Any question? Is it clear? Okay, so that is about group assignment. Like I said, in the group assignment, I think most important thing, the guidelines on the group assignment already uploaded in the My Times. You have to talk to the company what kind of problem that they wanted you to solve, yeah? So we don't specifically mention. Last year, I did mention about customer behavior. But when it comes to the company, students presented their proposal on the customer behavior. Some company didn't want to do on the customer behavior. They wanted to do on so many things. Okay, offline businesses, marketing strategy and everything. So please talk to the company as soon as possible. Hopefully by next week, you already identify the problem that you wanted to solve. So once you identify the problem that you wanted to solve, only then you know what kind of modeling is suitable for you based on the data set that they may want to share with you later on. Okay, so they will share whatever data they have with you all, but that's why I said decide your direction first. What problem statement that you wanted to solve. Once you know what you want to solve, and then based on the data shared with them to you, then you will understand what are the parameters, what are the factors that you need to get into the data set, and ask them if they have the information, they have the data, ask them to share it with you. Okay, so I think before the week 7, before our independent learning week, hopefully you already decided what type of modeling you wanted to use and what kind of problem you may wanted to solve. Classification ke, regression ke, dimensionality reduction ke, those kind of things you have to decide before independent learning week. So please don't do it very late, because of I had experience, but luckily last year, even though we have only 2 companies and we started the project in week 4 and onwards, okay, we invited the companies. I may want to invite the companies to our lecture, and maybe you can have some discussion with the companies person in charge. So one-to-one session. So I try my best to arrange for the meeting. Otherwise, whatever it is, please start and initiate the communication with the companies. Clear? Any question? Any question? No, no more question, on the group assignment. Clear? Okay, stand up. Then I give you questions. Stand up as usual. Please, you know me already from day 1. I already told you. Okay, otherwise student won't pay attention. Okay, before we start with data pre-processing, this is what we did already in week 1 until week 2. This is week 3 already, and week 3 we talk about data pre-processing. How many steps in data pre-processing? Very good. What's the first step? Raise your hand, you know the rules. Very good. Second step. Third step. 7th step. You raise your hand. Splitting the data set. Okay. Third, fourth. That's all. Half sitting. Step number 4. Very good. Identify and handling the missing value. You must handle. It's not just identify, sit down. Step number 6. No, 6. Feature scaling. And 5. Encoding. That's it. That's all. Okay, that is data pre-processing. And then we did also explain last week. We discussed about the difference between data analytics and data science. What's the main difference between data science and data analytics? Very good. Another one? Prescriptive hand? If you want to use that definition. Very good. That's all. That's it down. And data analytic. I told you already in my class, in your answer, I have 400 now. Sorry, your class is 69. Just give me the keywords. You give me the keywords straight away. Whatever other than that, then it's up to you. You want to put into 1 pages or 10 pages, I don't care. I saw the keywords straight away, you got the marks. Analytic. Diagnostic. Okay, that's good. What's another things that we discussed, the difference between analytic and data science? Very good on the data analytics. So you remember, okay? Then they give some example of applications, which one having the data visualization, which one is having the data pre-processing. Like I said, okay, this is also another important thing. Which one is a subset of which one? Very good. Okay, so it means both of data analytics and data science, they also involved with the data pre-processing, data visualization, data collection, any kind of activities that you wanted to do in data analytics or even data science. Okay, because data analytics is a subset of data analytics. Sorry, data science. Okay, so that is what we learn about this data analytics and data science. And then we also learn about the type of, in week 1, I did mention about the 3 types of machine learning algorithm. What's the first one? Very good. What's mean done? Wait. What's the definition? Put down your hand. Put down your hand first. Supervise. Put down your hand first. Put down your hand first. What's the definitions of supervise? Using label data. Give me an example of problem that you can solve in the supervised machine learning. Very good. Another one. Very good. Second type of machine learning algorithm. Very good. Definitions of unsupervised. Unlabeled data. Give me an example of problem that you can... Okay. Huh? Clustering. Another one. Another one. At the back. Huh? No. Oh, wait, yeah, he is the one. No. Problem. We didn't go to the type of modeling or algorithm. You mentioned clustering. Another one. Very good. Dimensionality reduction. Third type of reinforcement learning algorithm. What's the keyword of reinforcement learning algorithm? Huh? Feedbacks. Feedback consists of and punishment. Very good. Okay, so that is actually what we learn. And then, never mind, I sit down, everyone. Okay, so make sure you guys refresh about this kind of things. I always wanted to have two-way communication, so you will always alert and aware about what we are talking about previously. So that's what we discussed last week about this data analytics, introduction to data analytics and also machine learning. Today we're going to start with this topic on the data pre-processing. Okay, but you have two slides on the data pre-processing. The first one is actually in the PDF file. But in this slide, I will just focus on the a few slides only. For example, in this data pre-processing topic, they also involved with an explanations on the classification, clustering, dimensionality reduction. Whole practical exercises that we're going to do in this module, we're focusing more on the classifications, Okay, but if let's say later on in your group assignment you wanted to do on the dimensionality reduction, you wanted to do on the regressions, you wanted to do on the clustering, it's all depending on the discussion between you and the person in charge from the company. Clear? Okay, but in our practical exercises, I think all of the exercises on the practical, we will focus on the classification. And I will explain to you what's meant by the classification, the difference of classification, regression, clustering, dimensionality reduction. Okay, and reinforcement learning algorithm, we will have that topic at the end of our semester. Okay, but in the reinforcement learning algorithm, I said, I only have an example of practical in the R programming. So the coding on the R programming also will be shared. I already shared with you all in the My Times. Try to play with the R programming exercises on the reinforcement learning algorithm. Is it okay? Okay. But overall, from this third week topics, the most important thing that we should cover is the data pre-processing itself. Okay, once you understand the 7 steps that we mentioned earlier, then I think whatever algorithm that you wanted to use is all up to you, and it's not really, I mean, for me 90% importance of the data analytic come from your data pre-processing. So if you don't do data pre-processing properly, whatever algorithm you choose, that's why I don't care KNN ke, logistic regression ke, you're going to learn knife Bayesian theorem ke, I don't even care what modeling you wanted to use. Okay, because the modeling is your choice, it's an option. Okay, you can have many types of algorithm, but this is the most important topic. And this is the most important thing that you need to do before you apply any kind of machine learning algorithm. Again, first step, what is it? Second step? Third step? Fourth step? Fourth step? Don't forget handling. Fifth step? 6, and last one, by now everything must be in your mind. Okay, that is the formula for data pre-processing. Okay, but not compulsory the whole 7 steps you have to do, because whatever it is all depending on the data set shared with you. Okay, whatever data shared with you, only then you can see whether you need to do encoding ke, you need to do feature scaling or not. That one is depending on the data set that shared is with you. Is it clear? Is it clear? Okay, now before I start talking about the data pre-processing again on your attendance, I don't want to miss the attendance by the end of my lecture. Okay, so again, those 7 steps, by now everyone have to remember and understand what is actually about the 7 steps in data pre-processing. Okay, I have the PowerPoint slide explain on the data pre-processing 7 steps. Okay, but I will go to the PowerPoint slide first before we go to the PDF file. The PDF file also talking about data pre-processing. They're talking about the type of anomalies of data. Okay, I think it will be easier during practical later on. I share you some data set in Excel.csv, then you will identify what is the problem with the data set. From there, you can understand how to pre-process your data. Okay, data pre-processing, don't get confused. Sometimes people call data pre-processing as data cleaning. Okay, you clean the data first. It's similar step. Okay, so still 7 steps in data cleaning. Okay, so you have to do that before you apply any kind of machine learning algorithm. Now, let's go to your PowerPoint. Done? Attendance? Done, Okay, let's go to your PowerPoint slide first. Okay, we know that data pre-processing has 7 steps. Why we need data pre-processing? Why you need to clean the data set first? Why do you think you need to do cleaning first? Huh? Missing value, to handle the missing value. What else? Why you need data pre-processing? Generally, why you need to pre-process your data? Why can't you start away, once your company share the data with you, straight away do the modeling? That's why just now when people talk about KNN lah, logistic regression, I don't care. I was really aware and really concerned on this data pre-processing. Why you need to do data pre-processing? Let's talk about it. Your friend mentioned, sorry, it takes time for me to remember your name. Russell, right? Ryan. Okay, now I remember. Okay. Ryan mentioned data pre-processing. You need data pre-processing because of you need to handle the missing value. But sometimes not every data set have a missing values. Sometimes you have a very complete, perfect type of data. But it's very rare lah. Very rare. Okay, I believe the data that you will receive from the SME later on for your group assignment. No comment. Okay, it will bring a lot of headache, not just to you, to me as well. Okay, so that's why you have to pre-process your data with all of this kind of method. Okay, that's why in your data set you have some raw data, many kind of type of raw data, not just to handle missing value. But good answer from Ryan. Any other reason why you need data pre-processing? Why you need to pre-process your data? Why you need to clean your data? Inconsistency. Okay, good also. Okay, because of that, in data set also having an inconsistency. What else? At the end of the day, what is it? Noises. You are talking, every one of you talking about the type of anomalies. What's the most important thing you need to pre-process? Why you need to clean your data before you apply any kind of modeling or algorithm? Why? Is it to filter what? The data into? Huh? Categorical or numerical. Okay, that's also another thing that we have to discuss. Sometimes in your data, okay, before that, since you are talking about categorical and also numerical, for algorithm, what kind of type of data is suitable for any kind of algorithm that we want to learn later on? We didn't start algorithm yet, we are still data pre-processing, so I don't go yet to logistic regression, KNN, navigation network, not yet. We are talking about your data set now. Data set, what kind is the most ideal type of data in your data set that can be used for your algorithm? Categorical ke numerical? Why? Why numerical? You are first year student, second sem, correct? First year, second sem, correct? First year kan? All of you? Oh, some of you are second year. So you already learn about computer programming, right? Basic computer programming. Why you need numerical data? Why you need numerical data? Come on, why you need numerical data? Nak berdiri ke? Why do you need numerical data? Hey, come on guys, you computer science student. Anyone in your business student, you can sit down. Computer science student, I will ask you to stand up after this. Why you need numerical data? Huh? No? Huh? Louder. What's your name? Kayi. Why you need numerical data? Why algorithm need numerical data? Since your friend, what's your name, sir? Jonathan talking about categorical and numerical. Yet that one is step number 5, encoding. Why you need numerical? Computer science student, come on. Why you need numerical? You already learned computer programming, right? Data structure and algorithm you already learned? Why you need numerical type of data? With the efficiency, the last part, talking about the accuracy, precision and recall. Why you need numerical type of data? Okay, give me example of numerical. Betul. See, let's start basic type of data. Give me example of numerical type of data. Age, name, CGPA, CGPA, numerical. Talking about numerical categorical. Nak tengok ni, faham tak faham ni numerical or categorical. Numerical type of data, age, CGPA, what else? Height, weight, salary? Salary numerical. Grade, A, B, C, D? No. Colors, blue, black, white? No. Now you understand what's categorical and numerical. Now back to my main question. Why you need numerical? When you do data analytics, sama je, similar concept. You learn in computer programming, you learn data structures. Most of the time you are talking about numerical. Why you need numerical for the data analytics as well? What is it? Quantitative. So qualitative you cannot use. Why? Because not machine learning. The computers itself, you learn binary kan? All the code are in binary, correct? Which is what? Binary is what? 0 and 1. You learn the conversion from, I don't know, decimal lah, whatever kind of thing of conversion. At the end of the day, will be converted into binary 0 and 1, 0 and 1. Correct or not? So your machine, your computer, similar like your machine learning algorithm. The algorithm also can understand only the 1 and 0, the numerical type of data. So whenever you've been given a data set in a categorical type of data, what it should do? Your machine should be do what? Converting. That's what you do in encoding. That's what I mean by the encode. You encode whatever data you have in categorical into numerical. Reason why? Because of your computers, your machine only can understand numbers. Clear? Clear? That's why you learn in computer programming kan? What you see, you learn computer programming with the code and everything. What you see is actually using your high-level language programming. Correct or not? The one that you understand. Okay, but behind it, if you go behind it with all the data, that's why you learn also data structure algorithm. Behind it, everything is converted into binary lah, decimal point or whatever lah. I forgot already that kind of machine learning. Machine, what they call the topic? I can't remember the module. That's why you do the conversion. So similar here in data analytics, you must do the encoding. So remember, step number 5, encoding is to convert any categorical data into numerical. How? I will discuss with you later on how. Okay. Why? Because of just now what Ryan mentioned. Machine only can understand numbers. Machine only can understand numbers. Machine cannot understand categorical. If you give the data type is categorical, they will have some problem to process your data. So in data pre-processing, that is the most important thing that you need to do first. Check your data set. If there is any categorical data type, then you must do step number 5, the encoding one. Clear? Okay, and of course towards the end, like what Raya mentioned, the efficiency. That is what we're going to learn in the topic of performance measurement. Every machine learning algorithm, any data analytic that you wanted to use, we start with data pre-processing. Pre-process first, clean everything, check whether they have categorical or not, convert into numerical, and then blah 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 blah, and then you apply machine learning algorithm, KNN ke, regression ke, navigation ke, SVM ke. Then at the end of the day, don't forget to include the performance measurement. To include the performance measurement, that's what we're going to learn: the accuracy, precision, recall, MSC, RMSC, MAE, and many more lah. Okay, so only then you can understand which algorithm is the best for your data set. Understand the step, the flows? Clear? Okay, so you have this data pre-processing or data cleaning, or sometimes they call data cleansing, because of you need to convert any kind of anomalous type of data. Okay, you have to solve any kind of anomalies inside your data set. Either you have the outliers ke, meaningless data combinations ke, missing values ke, scaling problem ke, inconsistency ke just now. Then what we go in detail in the PDF file later on. Okay, so because of this reason and the reason that I mentioned just now. Because of the machine may not understand any problem including the categorical type of data, and because of your machine only can understand numerical data only, and at the end of the day it's going to ensure your machine learning algorithm that you choose or you selected can perform very well with the machine learning algorithm you chosen. Clear? Is it clear? Okay, so that is actually why you need data pre-processing. Now we move to the next step in the data pre-processing. Okay, now this is just a diagram. For example here, all the data that you will be received later on from your SME, they are all raw data. It's going to be a raw data, and the raw data consists of all the problems that you can have in the world. Missing values lah, outliers lah, inconsistency lah, redundancy lah, sometimes blank. Trust me, sometimes they have the column, they have the factors, but blank, nothing at all. Okay, sometimes I don't know whether you guys or some other student asking me about their data set consists of too many zeros, whether we can accept zeros or not. So those kind of things will be appeared in your raw data here. Okay, so that's why if you yourself, if you receive that kind of data, do you feel happy? Do you feel happy if you receive this kind of data? Of course you're not. Okay, what you can learn from that kind of data with so many problems inside the data set. So that's why you need to do data pre-processing here. Okay, most of the time, from the raw data you can see the size is become smaller, right? Okay, because of sometime when you handle the anomalies, for example, the missing values, there are two methods to handle the missing values. Either you remove or you do the imputations. Okay, if you remove, then definitely your data set will become smaller. Okay, but there is no rule of thumb saying that all the data set you cannot remove your data. Certain situation you can remove the data, and that's why it becomes smaller here. And this is your cleaned data, and this is where you need to use this data with any kind of modeling. Okay, this is where you got the KNN lah, regressions lah, naive Bayesian network lah, artificial neural network lah, whatever algorithm you wanted to use, it will be here. Can you see? Where are we now? We are still here. Still long way to go. Okay, before you apply your modeling or your algorithm. Once you apply your algorithm, this is where you got some insight. Insight is depending on the performance measurement, your accuracy of your modeling, your precision of your modeling, your result. Your result that you have got from the modeling, you apply on the data set, the clean data set, then you can give some prediction, insight, some recommendations. This will be your final output. So same goes to your group assignment. You will receive your data set here from many sources. Many sources. Don't be surprised. From one company, you have to ask another company later on to integrate. We call data integration later on. The data set to make it your one major raw data set. Okay. From here only you clean, then you do your data pre-processing, all the 7 steps if you need. Then you will get this clean data set. Only then you can apply the machine learning algorithm. Okay, so you will learn about data integration, you will learn about data augmentation, data pre-processing we're going to learn today. Okay, so after that only you can get the clean data, then you can apply the algorithm. Clear or not? Okay, now that is basically how the data pre-processing look like. Any question? Any question? No, Remember, I told you already the 7 steps is very important. Starting next week, I will have more questions to ask regarding this 7 step. Only from this 7 step. Like I said, I don't care the algorithm, what you wanted to use, what kind of algorithm you wanted to use. It's all up to you. You decide. Okay, so in my case, as long as you can give a good insight at the end of the day, it's all depending on here. Here. The 7 step, you don't do it properly, then definitely will affect your insight. Here, in the modeling, whatever algorithm you wanted to use, I don't care. Even sometimes some of my students, they are so smart, they use something that is not even learned in the class. I don't care. GMM lah, nak tunjuk, show off kan? GMM lah, PCA lah, EM lah, expected maximization. Bila tanya, when asked what is expected maximization, they don't understand. Data soft for classification, but using GMM, Gaussian mixture model. Please, whatever you wanted to use here is all depending in here. Okay, in here is where you decide your clean data set. In here is where you decide what's the problem that you wanted to use. In here is the problem. Is here that you have to decide what will be your insight here, your output here. Clear or not? Inside here can be all the categories of problem that you want to solve. Classification, regression, dimensionality reduction, clustering, all this kind of thing will be determined from here. That's why I said data pre-processing is important. For me, 90% more important than modeling, than your insight. Sometimes people don't look on the inside. People look on your clean data because the clean data is more expensive. Modeling, anyone can, I mean, the algorithm is already created, it's already developed. You just have to call the library and it will do it for you. Like what we learned last week. Regression equation is what? Y is what? We're going to learn regression in week 5. Y is what? M is what? How to calculate the slope? X2 minus X1 lah, Y2 divided by Y2 minus Y1 lah. Itu if you have only 2 data. If you have thousands of data, are you going to calculate one by one? That's what I mean. The modeling here is no problem. You just call the regression modeling, the library, it will do it for you. Okay, and that is what data pre-processing, data cleaning is all about. Now, let's move on to the first step. I need to divide my time. It's 12:30. Now, you have 7 steps. Step number 1 is acquiring data set. What's mean by the acquiring data set? What's mean by the acquire? Getting the data set. But getting the data set is not just about get the data set. That's it, done. Whatever given to you, I've already got the data set. Then I can apply the algorithm. No. In the acquiring data set is actually more than just getting the data set. The most important step in the first step here is to get the correct data set. Correct is the keyword. It's not just getting the data set. What's meant by the correct data set? What's meant by the correct data set? I think in next week or during regressions, we will have a topic on the classification and regression. No, we don't cover regressions. I think so. You will be asked to find a data set. Now, let's do some practical. Maybe I can give you 5 minutes. Open your browser. Try to find the correct iris data set like mine. That's what I said. Correct data set. It's not just getting a data set. Usually, this is how your data set will look like.
Сьогодні я китайця туди.
This one. This is a common. Tak nampak. Why it didn't display? Okay, sorry. Okay. This data set. Can you see it? In what type? Or file? Numerical, of course. Is they all numerical? No. You have one column with categorical. Which column? Description. What you should do? Decode? Encode. Encoding. You should do the encoding now. This. Okay. In the step number 1, acquiring data set, my key point, the most important thing is to get the correct data set. And usually in the exam, they already shared the data set to you lah, so you don't have to worry. But in the practical, I can do this. I don't share the data set to you. I ask you to find the data set. So you have to find the correct data set. I think in one of the week, we will use this data set called weather data set. Next week, this is going to be your homework. I want this exact data set for next week. Can you do that? During practical. You don't get this correct data set during practical, I won't start my practical. Because that's the first step. Kalau first step you tak betul, if the first step you don't do it correctly, how can I move to the second step and onwards? You understand or not? I want the exact data set like this one. Of course, I will not share in my times. You have to find it. I want exactly like this data set with how many columns? How many columns? How many columns? Tengok nak read data set. It's step number 1 tau. We're still step number 1, acquiring data set. How many columns? 8. Okay, now in the data analytics and machine learning, we don't call it column. Budak-budak business je. Business students only usually call it column. For computer science student, we call it as parameters. Remember, this one will ask. Parameters, factors, attributes, features, variables. Again, parameters, attributes, features. Dah repeat ke features? Sorry, features, parameters, attributes, variables. Apa lagi satu tadi? I forgot. Ada 5. Okay, there are 5 names, different names just for columns. So computer science students, data analytics students, we don't call column. Okay, I will use it alternately, but most of the time I will say either features, variables, parameters, attributes, or variables. Variable dah sebut ke? Dah. Sorry, I'm old already. Okay, so parameters, features, attributes. Belum. Parameters, features, attributes, variables. What's another one? Factors, yeah, sorry, factors. Thank you very much. Factors. That's only for column names, alternate for columns. Alternate name for rows, we call objects, observations, or sometimes people like to use record. Okay, but most of the time in my class, I will use either objects or observation. Clear? Now, here you have 8 features, 8 factors, 8 variables, 8 properties, 8 attributes, and you will have around more than thousands, 10,000 objects. Let's say I ask you to calculate the slope. Can you do it? Can you do it? Of course no. You have 10,000 objects. Okay, and that's why you just have to use the machine learning algorithm. It will solve it for you. I will teach you how to do that later on. Yeah? So next week as an homework, I want this data set, the correct data set. That's it. Acquiring data set is to have the correct data set. Okay, with these 8 columns or 8 features or 8 attributes or 8 parameters or 8 factors or 8 variables with 10,000 of your objects or observations or records. Clear? Clear? Then try to study a little bit about the data set. So in here, you know that you already have one data set which is in categorical type of data. The other 7 are actually in the numerical. So that's fine, and this is the only your problem. We will learn about encoding later on. Clear or not? Your homework next week is to give me this one. I want to see who have the skill. Some of you say, alas, easy lah sir, easy peasy to find the data set. From where? GitHub lah, Kaggle lah, even Google. You just browse sahaja, you will get the data set. People say like that. But to get the correct data set is another level. Okay, I'll challenge you to get this correct data set. Only then I will start your practical exercise next week. Clear? Clear, you have one way to do it. Try first. This one of course no marks lah, just to train your skill. Okay, that is acquiring data set. So you know how many numbers of columns, features, you have know the numbers of what objects, observations, and then go through the data set, find out if there is any missing value or not. Okay, you just scroll down. This is what you do if you don't learn machine learning or you don't learn data analytics. You have to scroll one by one, go one by one, check whether there is any missing value. Suddenly you saw 0 here, you saw 0 here. One by one. Right? You business student? No, who's business student here? So how you do your data set? You apply business analytic algorithm. Have you learned machine learning or business analytic in your school? Not yet. Okay, I got my students last semester. They do one by one, guys. So rajin, so hardworking. They check one by one. Highlight satu-satu. Highlight. They put highlighter. 0. Okay, highlight. Missing value. Okay, highlight. One by one. How many days you want to solve that problem only to solve data cleaning? Okay, so that's why it's very important you learn data pre-processing method in our data analytics machine learning topic. Okay, so go through that data, you will find out whether there's any anomalies inside the data set. That is step number 1, acquiring data set. You can get from Kaggle, you can get from GitHub, you can get from UCSI laboratory, you can get also from Google, you can get from anywhere else. Okay, even from Wikipedia, no problem. But to get the correct data set is the most important thing. It's another level. Clear? Clear? Step number 2 is what? After acquiring data set, what's the step number 2? Importing the libraries. So importing the libraries, there are 3 important libraries. Usually we use NumPy, Pandas and Matplotlib. You didn't learn Python programming yet, right? Some of you still didn't learn Python programming. So those who already learned Python programming, you know all these 3 libraries. NumPy is for the calculation and computation. Pandas is for you to have a data manipulation, data creation or data initialization. Matplotlib is if you want to use data visualization. So if you want to have a graph, bar chart, whatever, you must call the Matplotlib. But it's not just these 3. There are many other libraries that can be used for calculation, also for the Pandas, for the data manipulations, and also for the data visualization. But these are the 3 common libraries for the data analytics: NumPy, Pandas, and Matplotlib. Clear? Clear? So we will see later on in the coding where is the NumPy, Pandas and Matplotlib inside your code later on, when we start our practical. Step number 3, import the data set. To import the data set, remember the keyword is only read function. Read. Okay, read.csv, read.html, read.docx, read.pdf, doesn't matter, but the keyword is the read. But before you can apply the read function, you have to create the object of your data set, which is what we call df, the data frame, the one we do in the data in your practical. So that is the step on the importing the data set. To import the data set, you can either import the data set from 2 ways. Either you import from the Google Cloud or you import from the local directory. Okay, local directory, where it means your data is inside your device. Okay, later when you start our practical, you will understand the difference between local directory and also cloud. Okay, so that's step number 3. Step number 4, to identify and handling missing value. To identify missing value, I give you the keywords. Later on you will find in the coding, practical coding. For identifying missing value, the function we use is ISNA, I-S-N-A, or ISNULL, I-S-N-U-L-L. Okay, so you can use these 2 functions to identify any missing values. Now, earlier I showed you many types of anomalies. You ada outliers lah, inconsistency lah, redundancy lah, including missing values. For our practical session, we will only cover the missing values. Okay, so you can apply the similar concept, but of course the function and the command may be different, but the concept is similar. Okay, they also, if let's say for example you want to solve the inconsistency, you still have to use the identify method, and you still have to solve the inconsistency using the type of handling method. Okay, for the inconsistency. For our case, for our practical exercise, we only focusing on the missing values. Clear? Okay, so to give you some idea how you can do the step number 4. Identify, what's the keyword, what's the function name for the identify missing value just now? ISNA or ISNULL. To handle the missing value, okay, remember step number 4 is not just identify, you must also handle. You identify, you must handle the missing value. To handle the missing value, there are 2 ways. Okay, 2 ways to handle the missing value. Either you remove or you impute. Remove, you are using the function called drop-na, D-R-O-P, na. Na is actually not available lah. Okay, so drop-na, that is the first method, the easiest method for you to handle the missing value. Simply remove. Now, my question, just now the weather.csv dataset have 10,000 of rows, objects. Let's say 9,099 and 9,999 lah. Of your data in your data set have missing values. Let's say you apply drop-na, what happened? You only have 1. Okay? Okay or not okay? Of course not okay. How you can process, how you can actually do the modeling for 1 rows of data, for 1 object only. Nothing you can learn. Okay, so that's why missing values to handle, if you are using the drop-na function or removing function, it's okay. No problem. Only if 1 or 2 lines that you want to remove. If 90% of the data have to be removed, and then definitely of course not okay. Then you have to use the second method, is what we call as imputation. Okay, for computer science students, we call imputation. For other kind of students, you call replacement. Okay, you replace the missing values with some other value. Okay, to replace the missing value, there are 3 methods. To impute the missing values, there are 3 methods. Either you are using mode, median, or mean. Clear? Mode, median or mean. This one, the whole thing we discuss, we will do it practically in your practical. So mode, median and mean to replace or to impute. Mode, if you have a categorical type of data. So just now in your weather.csv data set, which column is categorical? Description. So in the description column, if there is any missing values, you can actually replace it or you impute it with the mode value. Mode is what? The average of the categorical data lah in your categorical columns or features. Okay, that is for categorical type of data. For the numerical type of data, you have two options. Either you can use the mean or you can use the median. Have you learned how to calculate the mean in the school? Yes. You do manual. Can you do it manually if you have 10,000? Of course no. That's why I said you are so lucky. You are here in this class, so we learn the easiest way using machine learning to calculate the mean and or median for the missing values for the numerical type of data. Clear? Okay. And to do that, either you want to impute with the mode ke, you want to impute with the mean ke, to the median ke, you are using a function called fillna. Fill. Okay, so fillna is for you to impute or replace the missing values either with mode, median or mean. Okay, mode, median or mean. So that's step number 4. Any questions so far? Is it okay? Okay, step number 5 is encoding. Encoding is when you convert or you transform any categorical data into numerical. Question just now I asked, why? Can understand the numerical. Good. Only numbers can be understood by your machine. So you have to do encoding. To do encoding, okay, you know the why reason. Okay, to do encoding, how to do it? There are 3 methods that we're going to learn in our lecture. Okay, first one is one hot encoder. Number 2 is label encoder. Number 3 is dummy function. The 3 functions are all similar. Purpose is to encode categorical data. Again, I repeat, dummies, one hot encoder, label encoder. But most of the time in your practical, they are using the label encoder method. So doesn't matter. Tak kisahlah you wanted to use a dummies ke, you want to use encoder, label encoder ke, you want to use one hot encoder ke, they all purposely for the encoding. Step number 5. Step number 6, feature scaling. Feature scaling, question, why you need to do feature scaling is because this one, you want to standardize and normalize your data. Sometime in your data set, okay, let's see, we go back to your weather data set. Not this one, No, this one, Most of the students, they got this data from Kaggle or GitHub, but I don't want this one, I want this one. Okay, so this one, you can see sometime your data from big negative value to big positive value. So the range is very big. The range of your data for one feature is very, very big. Problem to your machine later on, problem to your algorithm later on, because of the range is too big, it will take long time for it to be processed. And that's the reason why you need feature scaling. You want to standardize or you want to normalize the range of your data set. Clear? How to do it? 2 ways. Either you are using min-max scalar or you are using standard scalar. Clear? Next week I will ask, or maybe before we end the session, I will ask the question again, min-max or standard scalar in the feature scaling. Got it? Okay, and last but not least, what's the last step? What is the last step? Splitting the data set. You split the data set into 2, training and testing. Okay, you must split your data set into 2, training and testing. Okay, now, remember the keyword. The data set, just now you got 10,000 of data set. The 10,000 data set with 10,000 objects in the data set. It must be splitted into 2, training and testing. Why? Because training will be used for learning. Testing will be used for validation. So you want to validate what have been learned by your machine is correct or not. And that's why Ryan mentioned just now, last step, you do the performance measurement. So if the accuracy is high, so meaning that your machine learned correctly in here. Got it or not? Training for what again? And testing for validation. Which one is bigger? Why? I always ask why and what and how. These 3 questions is a very common question. Why you need more data on learning? Why you need more data on training? Learn very good. So give me example. I give you example. You have 14 weeks, correct? For your data analytics and machine learning module with me, you have 14 weeks. How many weeks you only have for final exam? How many weeks you have for final exam? For my module only. How many weeks for final exam? Only one. And that is final exam for what? The final exam is for what? To validate you. You faham ke tak faham my module? You understand or not my module? That's why the testing set is splitted very little compare you test training data set. You must get your machine to learn. That's why you need from 14 weeks, 13 weeks, you have to come to the class for the learning process. Correct or not? And 1 week only for your final exam. Okay, and that is what we call a concept of Pareto theory. Okay, Pareto theory, you have to decide, you have to divide your data set, split your data set into training and testing, where the training data set is more than testing data set. Usually we use 80-20. 80 for the and 20 for the most of the time. 70-30 okay? 60-40 okay? 60-40 is it okay? 60 for what? If let's say okay for training, still acceptable, huh? Still acceptable. I saw some people using 60-40. Now main question, 50-50 okay? Then cannot. Why? Very good, because you don't have enough data to be learned and to be tested. How you want to compare? You always have to compare. That's why you validate here. If you have 50-50, then how you want to compare? And that's the reason why you must have training data set bigger than testing data set. 82-28, 82-18, can or not? 82 for training, 18 for testing, can or not? Can. As long as your training data set is bigger than your testing data set. Clear? Clear? So that is actually about this 7 step in the data pre-processing. Okay, I have 8 more minutes. Okay, now for the PDF file, this one I just go it very quickly. Which one is the important, and I will highlight it. Okay, so you learn already about data pre-processing. Okay, and this is some of the reason why you need to pre-process. Macam-macam lah. Just now, Ryan mentioned about accuracy, completeness, consistency. Forgot your name. Sorry, miss. Huh? Priya mentioned about the inconsistency just now, timeliness, believability, all this kind of reason why you need data pre-process to clean the data set. Okay, and this is where the data set data pre-processing coming in, starting from the data sources until you get the insight. Okay, but I think I showed you the diagram just now, the easiest diagram. This one, similar things, huh? Okay. And then example of tasks in data pre-processing, data cleaning, you got data integration. The one that we discussed just now mostly is here. Yeah. Okay, but you sometimes have data integration, you have data reduction, you also have data transformation, data discretization. Okay. Data integration, if let's say you got in your assignment, group assignment, the data set is not enough, you want to combine, then we will learn how to merge the data set. The function name is merging, merge. Okay, so you merge or combine the data set. Data reduction is where you have the dimensionality reduction, usually for image processing. Example, you learn about resolution kan in your images. Okay, if let's say you put high resolutions into your cloud to store the images, it will consume spaces. Sometimes you can use the dimensionality reduction where the quality of the images from the original to the one that you store in the cloud is similar, using this concept of dimensionality reduction. This one we didn't learn lah. That one is under unsupervised type of data. Your case, like I mentioned, we mostly using label data, so supervised, and focusing more on the classification. Okay, data transformation, just like feature scaling just now we learned. And this is an example of type of anomalous data. You got incomplete, noisy, inconsistent, and intentional data. Please read. If you don't understand, you ask me. But most of the time, like I said, the anomalous type of data that we will cover in our module is missing values. Okay, we will cover on the missing values type. Okay, the incomplete lah. Okay, meaning that in the row, okay, they might have some blank inside the data set. So how to handle it? How to handle missing value? How to handle missing value? First method, remove. Second method, remove, use what function? Impute using what function? Fill now. Ada 3 value, there are 3 values for field now. What's the first one? Mean, mode, mode using for what type of data? Categorical, and the rest is for the numerical. Okay, so that is what we learned in the previously under missing data. This one is just a more explanation. This one I mentioned already, noisy data, and this one is just another type of problem in the data set. Okay, regression, clustering, I will just give you definition only. Okay, in the supervised machine learning algorithm is when you have your data is labeled. So now that's a good question as well. If you go to the weather data set just now, this one label ke unlabel? Your data set label ke unlabel? Label. You got every column with the name, so it's labeled already, so you don't have to worry this column is for one and the what. Okay, so this one is labeled data and you use for the supervised machine learning algorithm. Supervised machine learning algorithm can solve 2 type of problem. What's the first one? And regression. Classification and regression. Classification is when you want to classify. So for example here, you want to classify whether based on the temperature is cold or warm, for example, classify. Usually we do binary classification. That is classification. Regression is when you want to identify the value of the weather, the temperature. Okay, after you do all the modeling and everything, you want to know tomorrow is going to what the value of the temperature. So that is regression, and that's the only thing that we're going to learn in our module. But we focus mostly on the classification, where you want to classify, binary classification, 2 things, pass or fail, sleepy or not sleepy. I don't know, in my class. That's why I always like to ask my student to stand up. Okay, so that kind of things are binary classifications, okay, from your data set. Okay, and then regressions, the value just now. Clustering is almost similar to classification, but clustering just now is under what type of machine learning algorithm? Unsupervised, meaning that your data tak ada label. Your data is unlabeled, so you don't know whether this is belong to the cold or to the warm. You don't know. Cat or dog, pass or fail, you don't know. So you must try and error to ensure this is belong to this group. And that's the difference between clustering and classification. Clear or not? Okay, so that's how a regression, clustering and classification is doing, yeah? Okay, data regression, okay, I already explained. Now, this is the formula for correlation analysis. This is the formula. Guys, in the exam, I will tell you which formula you have to memorize. That's it. In my class, I don't want to go through. I mean, even this one is quite simple. Okay, the observed data and expected data. Observed data is the data given to you. Expected data is the one that you want to predict. Okay, so for example, in this example of nodes, you have the one observed in the outside of the bracket. The one in the bracket is the expected. So the algorithm already calculated for you. So this is the observed data. This one is the expected data. Using the formula, then you will get the output of correlation is equal to 500 something. In the correlation, you learn correlation. What's mean by the correlation? What's mean by the correlation? Relationship. You want to understand the relationship between 2 variables. Okay, you want to understand the relationship between 2 variables. For example, the temperature may be depending on the humidity, for example. So you want to understand whether these 2 variables are actually correlated or not. So if let's say you have 507, this is positive correlation. Good or not good? It's a good one. Negative correlation also is negative. It's a correlation, yeah? Okay, so that's why I don't want to go in details here. This is more on the statistical inference or modeling. Okay, that's correlation. Okay, please go through the example of calculation. I will tell you later on, but not today, which topic or which formula you have to memorize. Okay, then we focus on that later on. Covariance. Covariance is another calculation that you have to learn how to calculate other than mean and other than mean. Okay, covariance is actually the definitions of covariance. I think they explain it here. So you have a positive covariance and negative covariance. Okay, the formula is here. Okay, again, I think the easiest formula I put it in here. This one is not in your notes. Covariance for 2 variables, you can calculate by calculating the expected value of the multiplications of the 2 variables minus with the EX and EY. Okay, and that is what presented here. Okay, this line of calculation is presented by this formula. Okay, if let's say you cannot relate with the formula at the top, you can use this formula as well. Okay, so that is for the covariance. Next one, this one done. Data reduction, dimensionality reduction. I think I told you already about the image processing just now. Okay, this one you can just skip. Okay, in the regressions, what the equation for regression just now? Y is equal to mx plus c. You will learn simple linear regression. You will